What's up, my chemistry students? I am Mr. Kim, your chemistry teacher. If you did not know that, please see me tomorrow and I will make sure you know who I am. It is still Thanksgiving break, and here I am at home making a YouTube video for you guys because I know some of you guys aren't too fond of the videos I give you, although I try my best to give you very entertaining speakers. But for those of you guys who still fall asleep while taking video notes, I hope you do not fall asleep to my monotonous voice. Okay. As you can see, this is my computer desktop, my personal desktop. Very colorful and nice. You can see this worm over here. This almost looks like a single bond from chemistry. This guy over here looks like, I want to say, a silicon atom. And maybe this guy can represent this electricity over here, represents electrostatic forces, and this can be hydrogen bonding. You know, chemistry is all around us. As you can see, we have our chemistry folder over here. It shows how much I care about each and every one of you guys. So if you guys are falling asleep, please wake up. Let's begin. So I'm just going to briefly talk about bond length. We're going to be talking about that more tomorrow, and then doing some practice problems. But just as a brief intro video, let's just talk about Bond, James Bond. This guy, he is very good at what he does. He knows how to make assassinations look like child's play in the movies. Okay, I highly do not recommend assassinating anyone, but since we're in chemistry class, let's talk about some chemical bonds. Okay, so here we have three pictures over here, three diagrams of three different molecules. And it's a very self-explanatory diagram, but we'll go over this. So we have a single bond over here, as you guys know, should know by now. We have a single bond, and we have a double bond and a triple bond. Okay, we know that in a single bond, we have one electron being shared from this atom over here, this carbon atom over here, and we have one electron being shared from this carbon atom. For a double bond, we have two electrons being shared from this atom and two electrons being shared from this atom. For a triple bond, we have three electrons from this atom and three electrons from this atom. Okay, bonds are the sharing of electrons. Okay, so we have, or covalent bonds. So we have here three different distances. Okay, these are what you call a bond length. Bond length is the distance from the nucleus of one atom to another atom. The distance between the nucleus of one atom to the nucleus of another atom. So this is carbon's nucleus, that's carbon's nucleus, and for a single bond, it's 153.5 picometers. Now, if you compare that to a double bond or a triple bond, this is substantially longer. This shows that a single bond is longer than a triple bond. Okay, so I want you to take about 5 seconds, plus or minus 25, why this might be so. Okay, time's up. So I know a lot of you guys probably thought, well, maybe the single bond, it's weaker. It's just a thinner bond. Okay, it's like like bamboo stick. Bamboo is very strong. I take that back. It's like a balsa wood stick. It's very fragile. Whereas you might think, triple bond is like bamboo, and that's a very good thought. It's a very good conjecture. But here is a misconception many people have. A lot of people think that a single bond is somehow weaker than a double bond, okay? Or a double bond or a triple bond. This is not the case. A single bond is weaker because of the distance, of how far that distance is from one nucleus to another compared to that of a double bond or a triple bond, okay? A single bond shares one electron each from each atom, so two electrons. Double bond shares 4 electrons total, and a triple bond shares 6 electrons total. The more electrons you share, the shorter the bond length, okay? The more electrons you share, the closer you are. Think about a friendship, you guys. You're in a zombie apocalypse, okay? Zombie apocalypse. And you have a whole bunch of electrons you're sharing between you and your best friend, which means you'll probably hold his or very tightly. Okay, if you're running around and you have your friend's hand, you're holding it tight, then chances are you probably won't die very quickly from the zombies, from the walkers. However, if you're not sharing too much electrons, if your friendship isn't the strongest, you probably would feel kind of awkward holding his or her hand very, you know, very tightly. So you're probably gonna keep him 10 to 20 feet away from you. If that's the case, the chances of you getting eaten or you or your friend getting eaten by a zombie in a zombie apocalypse is very high. Okay, this is why sharing only two electrons causes this distance to be further, and the further the distance is between these atoms, or the larger the bond length, the greater the distance of the bond length, the weaker the bond. Okay, this is why single bonds are weaker than a triple bond, because the distance, the bond length is much greater. Not because a single bond is made out of bamboo, or made out of balsa wood compared to the bamboo structure of a triple bond. That is not the case. All right, I hope you guys have not fallen asleep. I will see you guys tomorrow, and I am logging off now. Thank you so much for watching, guys.